All right, so 86. I'm guessing this is chapter 2. Yes? No?
No, it's 1.
1? Okay. That's why I thought.
Yeah, it's the very, very last one.
Oh! So the one about the hurricanes. The one about the hurricanes? Okay, okay. All right. Well, maybe I don't need this. This is the one that says, it gives you a table. 86 says, what's the relative frequency of direct hits that were at most category 3? What does at most mean? 3 and under, yes. If you could be at most 12 to eat off the kids' menu at Denny's, you can't eat off the kids, right? It's that or less. So at most category 3 would be 1, 2, and 3. And you just add those up. Okay. Yeah. So you got to know what at most means, what at least means. Right? If you can have at most 6 people on an elevator, and there's a 7th person trying to get in, you're like, get out of here. Yes? Maybe? No? Yes?
I would do like 87.
Is that okay for you?
Yeah.
Okay. Oh, well, 87, this is the ones I told you guys, you've got to read section 1.4, right? So read section 1.4, see what the terms are. There's terms like experimental units, control, lurking variables. Ugh, that's some good shit now. You've got to use the 1.4 terminology here, right?
What about...
Yes?
Can you explain how to find outliers again for like 2 and 3?
So right now, we have just a subjective way to figure out outliers. So the one problem where there's really outliers is very obvious what they are, because when you construct the stem and leaf, there's at least one that's, so what would be like a real quick way to call an outlier? An outlier has to be a data point that is, what would an outlier be?
Like 1, 2, 3, 4, and 55.
Yes, something that's very far away from most of the data, right? So if somebody was 7 foot 9 inches tall, they are an outlier, because that's very far away from where I'd expect to see stuff. Yes, so we will discover more specific ways to identify them, more calculation ways to identify them, but right now it's just subjective.
So did you just say like, I believe that it is this one? Like,
Because it's so far away from where the rest of the data is. Beautiful. Yeah.
Number 76.
Oh, 76. That's a good one.
The prison.
Yeah, the one
You want
about.
us to like answer A, B, C, D, or like how do you want it?
Say again, sorry.
Like you wanted us to like...
I want you to, yeah,
Just
do the
say-
problem. So 76, A, B, C, D. Right? Answer the questions. So, I mean, if,
Number...
anything else? Yes, maybe? Maybe? Okay. Do you remember what the question was about?
Oh, me, okay, yeah. There's number 11. Oh, yeah.
In chapter 1 or chapter 2?
Chapter 1. It's like 12.
No. Chapter 1, you didn't have to do number 11.
Well, it's 12.
Oh, 12.
Yeah, 12 through 23.
Okay, so in 12 you had to identify what kind of sampling was used, just like on the quiz. So if they divided into 12 groups, which 2 things could it be? If you just stop right there, you divide the population up into 12 groups. Cluster or stratify, because that's the first step for both of those. Cluster would be if I took everybody from some of the groups. But what happens here? Yeah, 4 of the groups are chosen at random. That's cluster. Yeah. I don't want to give too many of these away, but I couldn't stop myself. So you just got to know. So I'll never ask you a definition question, but you got to know what they are so you can use them correctly. Yes, just like on the quiz. Okay, so let's get back into where we left off. We finished the stuff about histograms. So really, the next thing we got to get into is something called measures of center. So it sounds very formal, but it's just how do we get an idea about where the middle of the data is? And what's the first thing that comes to mind when I say that? The middle of the data. Mean. So the very first measure of center is the mean, which is really just another name for what we call average. And to be honest, the word average means multiple things, but the way that we use it, we're actually referencing the mean. That's the technical name for what we call average. Okay. Plus, it's a 4-letter word, starts with M. Math people like those. Yes? Average. Yes. It's another name for the average. Can somebody tell me in English just how to find the average of a set of data? How would I find the average? Add them all up. Divided by how many there are. All right, you with me? We all know how to do this. One thing that mathematics tries to do is it tries to capture ideas that take a long time to say in tiny symbols. So this idea of atom, we're going to use the official, what's the official name for adding things? Sum. So we're going to use the Greek letter S, the capital Greek letter S, which is sigma. That symbol means add up these. So by itself, it actually doesn't mean much of anything. So if I asked you, take the square root of, all right, do it, take the square root. What are you going to say to me? You know, like square root of what, dude? Right. So this is the same thing. Sum up the what? So what do you think we're going to use to represent all the data values at once? We already have something from algebra. X. X represents all the values, right? It's the variable. So add all up. That's how you say that in Mathish. And the letter we use to represent the number of things I'm looking at, the number of things I'm looking at will be n, thank God. That is what the average formula looks like in Mathish. Right? So all math is trying to do when it creates formulas is capture ideas very succinctly, and we just have to catch up with the shorthand they wanted to use. So they chose the Greek letter S. Same reason the Super Bowl chose Roman numerals to make it look all official. You know, that's right. Until Super Bowl 50 came. Super Bowl 50 was just L. Not very. No, you guys don't like the Super Bowl? I'm sorry. That was dumb. Okay. Is everybody with me on this? So wherever I see this symbol, it means add Add what? Add these. So let's talk about that symbol real quick, just for a minute. So if I have this data here, did I even start you?
Yes.
Yeah, that's useful. Okay. So let's say I have this data here. Why'd I have to make it so gross? Too bad. Let's just focus on the sum. What would the sum of x be? Yeah, right? 27. Why was that easy? Because it's asking me to sum up something that I've got. I've got a list of x's. So what's the sum of the x's? 27. I can see it, right? I like you guys. You're all like, okay, yes. We can add numbers, Jeff. I feel so good. So what if I ask you this? That does not say square 27. That would be this. You guys see the difference there? This says square this. That would be 27 squared, and then whatever the hell that is. Is that 729? Don't trust me. All right. I think it's 729. This one, what does that guy want? Now watch, if you cover, we're going to see this freaking symbol everywhere. If you cover it, that's what list I need. Do I have a list of x squares yet? I got a list of x's, don't I? That's why that first one was easy. I already got them. Do I know what the x squares are? No, so let me go make them. What's the x squares? 25, 36, 49, 81. Now I can add them up. If you cover that, say, oh, I need a bunch of those. Let me go make a bunch of those, because then I can add them up, because that's what that symbol wants me to do. This actually captures a lot of mathematics. It's the more you understand the symbol, the more you know what to do. So, of course, what does that come out to be?
191.
191? Okay. I like it. We are going to see the symbol with a lot of stuff behind it, so we've got to kind of know how to build it. All right. Two symbols are used for the mean. One is for population, one is for samples. If it's a population, I'm going to use a Greek letter to make it all like official, right? And if a sample, I'm going to use our letters. So a population mean is mu. It's a U with an extra leg. I know it looks like an M. It is not an M. It's a U with an extra leg, right? It's a French cow. Mu, or whatever. That's a joke just for me. I don't care. That's a population mean. A sample mean is X bar. So if I said to somebody, okay, I got X bar of 7, they know I'm talking about a sample. They know that that is a statistic. So that's why we just gave them two different symbols, so I can quickly know what the hell I'm talking about. Which is always a nice feeling. Okay. I like it. So we haven't done any new ideas. We've just talked about new ways to ask you to do things. You know how to sum shit up. You know how to square stuff. But now we know the symbols that represent what to do with those. Okay. Why is there more measures of center than just the mean? We live in San Diego. There's a couple of really good examples of why I wouldn't want to use the mean to represent the middle of data. You ever go walking around La Jolla? What's in La Jolla? Seals. I love it. Huh? Money. So the people in La Jolla can afford to buy big old freaking houses, mansions. I like it. So I go walking by, I'm like, I won't ever be invited to things, let alone own it. Right, but so, my point is, I would never tell somebody the average home price for San Diego, because that is lying to somebody, right? I don't know if you guys can see it. So for another example we can see really easy, is income. Here's the motivation for this. Why this must exist. It's not called the motivation. I don't know how you want to do your notes. So let's say there's a company where these are people's salaries in thousands, right? And then you have the CEO, right? I'm not trying to be political here, right? The top 1%. No, stop. I love her. If somebody came, they're going to start working here, and I said, hey, what can I expect to make? And I told them the average. Is that accurate? No, the average of those I think is 180,000. If I said, oh yeah, the average 180,000, whoa. So a much more accurate thing to tell them is what's called the median. If you ever pay attention to articles, or news articles or news or anything about income, house prices, they always say the median house price, the median income. Because that does not include outliers. Isn't there an outlier in this data? Oh, hell yeah. The median is the number that is in the middle. So it's obviously a measure of center. Now tell me, what number is in the middle of this? 45,000, right? If there's four numbers, is there a number in the middle? No. In fact, what's another name for median? We already did this. It's the what percentile? How far do you want to go in? Halfway, so 50th percentile. That's just all it is. Half of 4 is 2. That's a whole number. Average the second and third to get the middle. That makes sense. If I had 5 numbers, the middle would be an actual number, right? Okay, so this one, if I told them, oh yeah, about 45,000, that's much more honest, right? So medians are not affected by outliers. Obviously, the numbers have to be in order, just like percentiles.
That was my question.
Oh, if I could reorder these any way I wanted to, I can make the median anything I wanted to. Then it would have no meaning, right? So they have to be in order. How you guys doing so far? So you all came into this knowing how to calculate an average. Now you know the symbols for it. And we already did P50. And we're just going to call that one, that's the most special percentile, it's the median, because it happens to be the one that's right in the middle. Okay, I like it. Maybe, maybe. So what's the median of this data? Yeah, it's 10. Oh, and here's the symbol for median. There was something in my brain I was forgetting. The symbol for median is like a sample mean that had a rough night. His little hat got all crushed. So it's an X with a tilde on top. That's the symbol for median. So here I'd say the median is 10 because there's an actual middle number. I love it. Kicking the ass. Yes?
Is that for both sample and population?
Yes. I like it. Okay. Nothing too new up here yet. So what about the third dude? You know there's a third dude. These two, now real quick, these two only work for quantitative data. Do you guys agree? Can I sum up hair color? No. Right? Can I average two types of cars? No. So these are for quantitative data only. I want something that works for qualitative data too. Because any set of data, I might want to know where the middle sort of is. This one is kind of weird. It's not too weird. It's called the mode. It's just weird to stop and think, how do you find the middle of a set of data that's just names? Well, it's sort of like the idea of where are they clustering. So if I had asked people, what kind of car do you drive? And 7 of them said Honda, and 2 of them said Tesla, and 81 of them said, I'm not trying to, let's just make it Hyundai. Yeah. I was going to do Ford or Chevy, but then people might get upset. Ford, Chevy, shut up. What is obviously the modal type of car? Hyundai, yes. Right? Because that one is the one that occurred the most. I'm sorry, I never said that. This is the one that occurs the most. So the thing that occurs the most is what we call the mode. And it's the only type that works with qualitative data also.
You said that number 2 was for qualitative or
No. Okay. Everything works with quantitative.
Okay.
Mode is the only one that works for names.
Okay.
Yes. These guys have to be able to add and do stuff like that. Take the average.
Is there a symbol?
No. One semester we did make up a symbol for it. Can you guys guess what the symbol was that we made up for it? I loved that they wanted to make one up and then they just made it capital M. I was like, all right, well, that works. All right. There is no official symbol for it. like it. So this also works with quantitative too, obviously, right? So if I had a set of data that looked like 1, 3, 3, 4, 5, the mode is obviously 3. I can have bimodal data. That's bimodal. Do you see that there's a tie? I'm sorry, I tried to make this room work a little better for you, but I almost did it. Yeah. What's the tie? It's bimodal. 3 and 4. Right? But what if it was this? Yeah, there's a winner. Don't just say the repeated ones and say they're all the modes. There is a clear winner for most, 5. So here the mode would be 5. So finally, we're sort of leaving definitions a little bit behind. This is stuff you can sink your teeth into a little more. You can calculate stuff. Right? Okay. There's one more that the book doesn't talk about, but I'm going to talk about. So everybody got what they want from here?
Yeah.
So we got mean, median, mode. And I still want to talk about a measure of center, and the other measure of center that's very often left out is called mid-range. What's the range?
Lowest.
High minus low. So it's like how far the data ranges. The mid-range should be the number that's in the middle of the high and low. What's really evil is, how do I find the number that's in the middle of two numbers? I take the average. And how do I take the average? I have to add them, right? Isn't that a little evil? Range is minus. Mid-range is add because you're taking an average. So mid-range would be high plus low divided by 2. So if I had data like, what you got, Jeff? 10, 11, 14, 21, 30. What's the mid-range?
30.
10.
What's happening? What?
Okay,
I love you guys. So what I need you to do is what I just wrote down, what we just talked about. Yeah, 30 plus 10 is 40, divided by 2 is 20. I hear some of you guys, but I heard 30, I heard 10. That was a little troubling.
It's high plus low divided by
So the mid-range, why does this make sense? The mid-range should be the number in the middle of the range. Mid-range. And how do I find, no, that's median. How do I find the middle of two numbers? I average them. 14 is the median. It's in the middle of all the data points. What number is in the middle of 10 and 30? 20. You see the difference? The mid-range just cares about the low and the high and getting the number between them. The median is the actual data point that's in the middle of all the data points. Those are two very different things, huh? So the mid-range only cares about the highest and the lowest. How do I find what's right in the middle of 30 and 10? In fact, those you can just tell me. What's right in the middle of 10 and 30? 20. There. That's the mid-range.
Okay, try a different number. Or a different problem.
Say again? Sorry.
Like, try a different problem besides that.
All right. So what have I had?
Four, 63,
Yeah.
50. Wait, what? Oh, well, hold on. Do it again, sir. Like, show me.
So this one was nice because 10 and 30 are easy.
Yeah.
What is the formula for mid-range?
high plus low divided by 2.
So it's 33.
Right? I wrote it down, right? Right? What's the highest one? What's the highest one?
63.
Oh, yeah,
63.
63 is
What's the lowest one?
4.
4. And then divide those by 2 because I'm going to take the average of those to get the middle of the range.
So whatever is the biggest number, that's the high, and the low is the lower number.
Yes.
Okay, I get that.
Okay. Cool. I like it. So does everybody see that the mean, median, mode, and mid-range could all be the same, but they don't have to be, obviously, right?
I like mean and then I don't know about mid range.
All right, you got to learn to love it, or else you'll. Yes. Sorry. Careful. So if I just rearrange these numbers, did I change what the highest one was? No. So the mid-range, don't even care if it's in order. You just got to make sure you get the lowest one and the highest one. Yeah. I like it. Okay, maybe. Okay. So, those are all ways to calculate the middle of a set of data. There are different ways. And one of them was because what if I don't have numerical data? Okay. And then one of them was, what if there's a lot of outliers, then I want to use the median, not the mean. You guys kind of with me? So that's why we have multiple ways to get the middle of data. I like it. By the way, the mode, I don't know if I said this, you can have no modes, right? Because everybody shows up once. You can have one mode, two modes, bimodal, or three modes, trimodal. If there's more than that, we're like, there really isn't any. Mode is trying to see where things are clustering. And if they're clustering in more than 3 places, they're not really clustering anywhere. So you can have up to trimodal.
So what do we have for? Just say
Then there's no mode. I like it. Not quadrimodal.
Mm-hmm.
I like it. I like it. Okay. So that really is just getting to understand what the words mean. The actual calculations in that is easy. Adding, dividing, stuff like that. Not a big deal. Okay. So what we need to do now is something that's going to be a little more complicated. And here's why we want to get this. Tell me this. Let me do it this way. Am I able to see everything? Stay with me. You're going to love this. We're actually going to go through the process of creating a formula that tells me what I want it to tell me. I always envision this formula in this chair. You got to like, tell me. So you don't get to see this very often in mathematics. You're given formulas, right? We're going to freaking make a formula. Tell me this formula. We're going to create it. We're going to make it tell us what we want. So here's the reason why I want one more thing to get from data sets especially. Can somebody tell me if there's a difference? Oh, get out. Let's do, yeah. You guys all see that? Red's not the best choice, but oh. Take a minute. Calculate for each one of those the mean, the median, the mode, and the mid-range. Calculate all 4 that we've learned. Yes. Huh? Oh yeah, sure. That's why I was asking you guys. I'll just switch back to. Is that better? Yes? No? Yes?
Yeah.
Okay.
Yeah.
Okay, so find mean, median, mode, and mid-range. Don't say anything out loud. I love that people are like, what's this? Be quiet. All the measures sensors, so find mean, median, mode, mid-range. median should be pretty quick because they're already in order and there's 5 of them. So just pick the number that would be, like flipping you off. What's the median for both sets of data? 5, because it's the number in the middle. They're both in order. What's the mode for this one?
5.
What's the mode for this one?
9.
What's the mean?
5.
Yeah, because they add 25 divided by 5. Mean here is still 5. And you notice how I made this go down by 3? And then made this go up by 3. So of course it's going to be the same. Because they add to be the same thing. And what about the mid-range? For both of them is going to be
9.
Right? All right. And the mode is the only one that's different, but the mode doesn't really tell me much about the data anyway. Do you guys see how the measure of center by itself is not enough? In fact, let me ask you this. You guys all know about like that website Rate My Professors, right? I still remember when we first heard about it, I was on the East Coast, and the next day you could see how all my colleagues had rated themselves. It was pathetic. They're all like, this guy's amazing. And somebody wrote essence of the essence, and I'm like, all right. Should we go? So there's another website that you actually have to pay money for, thank God, and it tells you grade distributions of teachers and all the courses they teach over the last however many years. Yes. Okay. And unfortunately, too many students nowadays go for the easy A teacher, which means you're not going to learn shit. So hopefully some of us want to learn. So if you knew, so let me ask you this. So you check out these 2 professors you're interested in. They both have pretty much the exact same Rate My Professor. They both teach at the same time. Everything. Right? But then you check on the other website, and one professor, let's say you're at university. Right? What's different at university? A D is passing. With me? So, if you know that one professor gives A through F, but they have an average of a C, right? So you know they both average a C, but one professor goes A through F, and the other professor goes B through D. You guys with me? Which one would you take? Well, it kind of depends. If you think you're going to suck in that class, who would you take?
The second one.
A.
Wait, no, B through D, because he just said
If you're going to suck in that class, you want to take the one that doesn't seem to ever fail anybody. So you can get that D, but that's still passing. Are you with me?
Yeah.
But if you're going to kick ass in that class, you knew you're going to kick ass,
You gonna get the first one.
you're going to take the one that actually gives A's.